Download this code from codegive.com, link in the description below. OK, let's embark on a journey to understand the infamous concept of dividing by zero, from a beginner's perspective all the way to a more advanced mathematical understanding. We'll break it down into 5 levels, with explanations, examples, and even some code snippets. Level 1, Elementary School, the sharing problem. Asterisk concept. Asterisk division means splitting something into equal groups. Asterisk explanation. Asterisk imagine you have 12 cookies and want to share them equally with 3 friends. You would divide 12 by 3, 12/3 equals 4. Each friend gets 4 cookies. Division is fundamentally about distributing a quantity. Asterisk what happens if you try to divide by 0, let's say you have 5 cookies and want to share them with 0 friends. Who gets the cookies? There's nobody to share them with. The question itself doesn't make sense. Dividing by 0 implies splitting something into no groups, which is impossible. Asterisk key takeaway. Asterisk dividing by 0 means sharing something with nobody, and that just can't be done. It's undefined. Asterisk example. Asterisk 6/2 equals 3, 6 split into 2 groups of 3. Asterisk 10/5 equals 2, 10 split into 5 groups of 2. Asterisk 5/0 equals that doesn't make sense. Level 2, Middle School, Inverse Operations. Asterisk concept. Asterisk division is the opposite, inverse, of multiplication. Asterisk explanation. Asterisk to understand division better, think about its relationship with multiplication. For example, 6/2 equals 3 because 3*2 equals 6. Division undoes multiplication. Asterisk why can't you divide by 0, if we try to divide 5/0 equals, we're asking, what number, when multiplied by 0, equals 5? There's no such number. Any number multiplied by 0 always equals 0, never 5. This is why division by 0 is undefined. Asterisk 0 divided by a number. Asterisk what about 0/5? This means, what number, when multiplied by 5, equals 0? The answer is 0, 0*5 equals 0. So, 0 divided by any non-zero number is 0. Asterisk key takeaway. Asterisk division by 0 breaks the fundamental relationship between multiplication and division. Asterisk example. Asterisk 12/4 equals 3 because 3*4 equals 12. Asterisk 0/7 equals 0 because 0*7 equals 0. Asterisk 5/0 equals no number works because any number *0 equals 0, not 5. Asterisk simple code example, Python. Level 3, High School, Limits and Infinity. Asterisk concept. Asterisk exploring the behavior of fractions as the denominator gets closer to 0. Asterisk explanation. Asterisk instead of directly dividing by 0, let's look at what happens when we divide by numbers very close to 0. Consider the fraction 1/x. Asterisk if x equals 1, 1/x equals 1. Asterisk if x equals 0.1, 1/x equals 10. Asterisk if x equals 0.01, 1/x equals 100. Asterisk if x equals 0.001, 1/x equals 1000. As x gets closer and closer to 0 from the positive side, x0, 1/x gets larger and larger, approaching positive infinity. Similarly, if x approaches 0 from the negative side, x0. Asterisk if x equals -1, 1/x equals -1. Asterisk if x equals -0.1, 1/x equals -10. Asterisk if x equals minus 0.01, 1 slash x equals minus 100. Asterisk if x equals minus 0.001, 1 slash x equals minus 1000. As x gets closer and closer to 0 from the negative side, 1 slash x gets smaller and smaller, more negative, approaching negative infinity. Asterisk limits asterisk in calculus, we use the concept of a limit to describe this behavior. We write asterisk lim, x rightward arrow 0 plus, 1 slash x equals infinity, the limit of 1 slash x as x approaches 0 from the positive side is positive infinity. Asterisk lim, x rightward arrow 0, 1 slash x equals dash infinity, the limit of 1 slash x as x approaches 0 from the negative side is negative infinity. Since the limit from the left and the limit from the right are different, the limit as x approaches 0 generally does not exist. Asterisk y still undefined, even though we can talk about infinity, infinity is not a number. Division by 0 still doesn't have a defined value, it leads to an unbounded, undefined situation. We cannot treat infinity as if it were a number in arithmetic operations. Asterisk key takeaway asterisk as we approach division by 0, the result grows infinitely large, or infinitely small, but it doesn't settle on a specific value. Therefore, division by 0 remains undefined. Asterisk code example, Python with math. Be very cautious with code that can lead to very large numbers. This is just for demonstration. Level 4, Calculus/Early University, Indeterminate Forms. Asterisk concept asterisk some limits involving division by 0 can be evaluated using L'Hopital's rule and other techniques. Asterisk explanation asterisk while directly dividing by 0 is undefined, some limits that seem to involve division by 0 can have a well-defined value. These are called indeterminate forms. Examples include 0/0, infinity/infinity, 0 asterisk infinity, 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 1 sub infinity /sup, 0 sub 0 /sup, and infinity sub 0 /sup. Asterisk example 1, the indeterminate form 0/0 asterisk. Consider the limit, lim, x rightward arrow 2, x sub 2 /sup, 4, /x, 2. If we directly substitute x equals 2, we get 2 sub 2 /sup, 4, /2 to 2, equals 0/0, which is undefined. However, we can factor the numerator, x sub 2 /sup, 4, equals, x, 2, x plus 2. So, the limit becomes, lim, x rightward arrow 2, x, 2, x plus 2, /x, 2. For x is not equal to 2, we can cancel the, x, 2, terms, lim, x rightward arrow 2, x plus 2. Now, we can substitute x equals 2, 2 plus 2 equals 4. Therefore, lim, x rightward arrow 2, x sub 2 /sup, 4, /x, 2, equals 4. Asterisk L'Hopital's rule asterisk a powerful technique for evaluating limits of the form 0/0 or infinity/infinity. It states that if lim, x rightward arrow c, f, x, equals 0 and lim, x rightward arrow c, g, x, equals 0, or both limits are plus or minus infinity, and if f, x, and g, x, exist and g, x, is not equal to 0 near c, then lim, x rightward arrow c, f, x, /g, x, equals lim, x rightward arrow c, f, x, /g, x. In our previous example, f, x, equals x sub 2 /sup, 4 and g, x, equals x, 2. Then f, x, equals 2x and g, x, equals 1. Applying L'Hopital's rule, lim, x rightward arrow 2, x sub 2 slash sub, 4, slash, x, 2, equals lim, x rightward arrow 2, 2x, slash 1 equals 2 asterisk 2 equals 4. Asterisk why does this work? L'Hopital's rule leverages the derivatives, rates of change, of the functions to understand their behavior as they approach a point where they both become zero or infinity. The ratio of the derivatives often reveals the true limit. Asterisk key takeaway asterisk some expressions that appear to involve division by zero are actually indeterminate forms. We can use techniques like factoring, L'Hopital's rule, or algebraic manipulation to evaluate the limit of the expression as we approach the point where the denominator would be zero. However, direct division by zero remains undefined. Asterisk code example, Python with SYMPY for symbolic differentiation. Level 5, Math Major, Abstract Algebra and Field Axioms. Asterisk concept asterisk division is defined in terms of multiplicative inverses, and fields require specific properties for these inverses. Asterisk explanation asterisk in abstract algebra, we formalize the properties of numbers and operations. A field, example the real numbers, complex numbers, is a set with two operations, usually called addition and multiplication, that satisfy certain axioms. One crucial axiom is the existence of multiplicative inverses for all non-zero elements. Asterisk multiplicative inverse asterisk for every non-zero element A in a field, there exists an element A sub dash 1 slash sub such that A asterisk A sub dash 1 slash sub equals 1, the multiplicative identity. This element A sub dash 1 slash sub is also called the reciprocal of A. Asterisk division as multiplication by the inverse asterisk division is then defined as multiplication by the multiplicative inverse. A slash B equals A asterisk B sub dash 1 slash sub, where B is not equal to 0. Asterisk Y0 has no inverse asterisk suppose 0 did have a multiplicative inverse, which we'll call 0 sub dash 1 slash sub. Then, by the definition of a multiplicative inverse, we would have 0 asterisk 0 sub dash 1 slash sub equals 1. However, another fundamental property of fields, and rings in general, is that for any element A in the field, 0 asterisk A equals 0. This means 0 asterisk 0 sub dash 1 slash sub equals 0, which contradicts the requirement that 0 asterisk 0 sub dash 1 slash sub equals 1. Asterisk consequences asterisk if we allowed division by 0, it would violate the field axioms and lead to logical contradictions. Many important theorems and properties of fields and other algebraic structures rely on the fact that multiplicative inverses exist for all non-zero elements. Allowing division by 0 would break these foundations. Asterisk example, illustrative, not a formal proof. Suppose we falsely assume that division by 0 is allowed and that 1 slash 0 has some value x. Then, asterisk 0 asterisk x equals 1, by the definition of division. Asterisk but also, 0 asterisk x equals 0, a fundamental property of 0. Asterisk therefore, 1 equals 0, which is a clear contradiction. Asterisk rings and zero divisors asterisk in more general algebraic structures called rings, division is not always possible, even for non-zero elements. A zero divisor is a non-zero element A in a ring such that there exists a non-zero element B with A asterisk B equals 0. In rings with zero divisors, you have to be very careful because you cannot always cancel terms in equations the way you can in fields. Fields do not have zero divisors. Key takeaway The prohibition against division by zero is a fundamental requirement for maintaining the consistency and logical structure of fields and related algebraic systems. It arises from the definition of division in terms of multiplicative inverses and the properties of zero. Allowing division by zero would destroy the very foundations of arithmetic and algebra. No direct code example is applicable here. This level deals with abstract mathematical concepts and axiomatic systems, rather than directly executable computations. The concepts are fundamental to the design of programming languages and numerical systems. In summary, the prohibition against division by zero isn't just an arbitrary rule, it's a necessary consequence of the fundamental properties of numbers and mathematical systems. As you advance in your mathematical studies, you'll see this principle appear in various forms and contexts, always reinforcing its crucial role in maintaining consistency and avoiding contradictions. Remember that the deeper you go, the more you realize the underlying elegance and structure that necessitates this rule.